So today I'm going to talk about the VP9 live transcoding system that Twitch is going to push into production by the end of this year. And when I was preparing these slides, I was thinking, wow, it's actually a pretty complicated story to tell. But I hope that by the end of this presentation, I bring you two pieces of information. The first one is for this talk, I'm really not talking about how the codec is designed. I know you guys all are experts. You know the 64 by 64 or the 35 modes of intra-prediction and all this filtering, all this mathematics. I'm not going to talk about that. I'm more talking about from a user's point of view. What is the logic chain to convert these fantastic features into business values, into the better user experience that we can offer to our viewers? Okay, say a few words about myself. For people who don't know me, I think I know most of you. For people who don't know me, I'm working for Twitch. I'm in charge of core video technology at Twitch. I'm in charge of the transcoding team, but also working on the player. I actually invented AV1 switch frame, which I will cover a little bit at the end of this talk. For my early career, I coming from a linear TV industry, so I work for chip company. I build equipment for TV stations. So I do come from a codec background, but now I'm doing streaming right now. So from a codec builder to a customer. Okay, so now say a few words about Twitch. Let me actually show a little intro video to you. Here we go.
It's bumped by classics, but he might fall and continue to get ball control. Look at this play from Kronovi. Big aggressive move by South Korea.
What? No, that's not a thing!
You beautiful individual.
Oh, I so just watching this stream. That's so cool.
You're teaching it the meaning of love.
No, he's not.
He is.
No, he's
He
not.
is going
No,
for
he's
it.
not. He's not. Oh, no. Oh my God, no.
Here's the hard carry. This guy is unstoppable.
This is a very simple thing that you can do, even if you've never seen it before.
Let's get more butter.
Say hi.
Oh, that's it, baby. What a way to end. Wow, what a game.
Really, that from an engineer point of view, I think the two biggest value that Twitch offer to this industry are two things. First, is we greatly reduce the barrier of doing broadcast. You don't really need to have an uncle who's a director in Hollywood. You just need to have this simple setup, and you have internet. You can broadcast on Twitch. And the only teeny tiny thing that you need to worry about, you need to find people who want to watch your video. And the second one is because of the low latency. So I was actually chatting with Netflix. Gentlemen, we were talking, so for our latency, for the low latency feature that we released at the beginning of this year, for our end-to-end latency from the moment the video hit our system, which is ingest point, to the video that's played out by our player, the median is 3.5 seconds. So in this scenario, you can see this guy is playing the game and people are chatting with him, and he needs to respond to this chat message in a timely manner. So this guy is actually a great gamer, but he's also a great entertainer. So he needs to like a multitasking, playing the game and also chatting with his people. So in this way, the audience are actually part of the content, and that makes Twitch so interesting to watch. So that's Twitch in a few words. And because we are mainly doing eSports and the gaming content, so we actually build a social network. It's a community of gamers. People come to Twitch to watch other people playing game and also to socialize with other gamers. This is Twitch's scale last year, and we've been consistently growing. So that's the number last year. This year at TwitchCon, which will happen in October, our CEO will announce this year's number. So I expect it will be much bigger. Okay, so just one example is a few months ago, actually in June, 2 months ago, E3 is the biggest gaming conference. And during this conference, we hit our new concurrent viewer record, which is 2.9 million. Next is the Alexa. I think many of you are familiar with this index measuring the popularity of websites. So if you look at our history from 2011 when Twitch was launched, we've been growing, like climbing up this ladder pretty consistently. And according to Alexa, we are the third most popular video website behind YouTube and Netflix. And I guess the second speaker will talk about what's going on there. So these are the background, but so I was mentioning in the beginning, I still haven't remembered what the second piece of information I want to tell, but I'll come to that. So because of this scale, because of the content we are servicing, why do we need to, what is the motivation for engineer to put together this next generation transcoding solution? And really it's coming from a business need. If you look at the 1080p60, this is the feature that we released in 2017, beginning of 2017. This actually reminds me of a story. I was working for OnLive, which is a cloud gaming company, and that didn't go very well, so it went down. So I was looking for a job, so I come to Twitch. And when I was interviewed, and at the end of that interview, my manager, who actually, he was the last interviewer. So he just basically come in and say hello to me, making sure everything went well. So he was asking me, he said, Yueshi, what do you feel about Twitch? So I say, so I just, without any thinking, I just say, your video quality really sucked. And for that moment, I really regret. I think this is such an impolite answer to such a nice question. And he wasn't angry. He said, yeah, well, that's great. Sounds like you are motivated. So after I received the offer, I actually call him, just say thank you and check a few things. And I was asking him one thing. I say, what do you want me to do at Twitch? He said, I don't know what you want me, I don't know what I want you to do. The reason I hire you is you come to our team and you yourself figure out what you want to do. And I would say, well, that's a really fantastic answer. This is really the fantastic team that I want to work for. So I actually, so I'm living in South Bay, so I commute 2.5 hours every day to come to the city to work, and that's been fantastic. Anyway, so back to that, the 1080p60 is one of the long-awaited feature that our community needs. And once we release that, it's really fantastic. Believe it or not, majority of our viewers can watch 1080p60. And that's due to 3 reasons. The first reason is our broadcaster really have good internet connection. So uploading 6 megabits per second is not a big deal for them. And in fact, in some Asian countries like Korea, Singapore, they even want to do 9 megabits per second. So they really have this bandwidth. And on the other hand, for the last mile, our viewers, most of the viewers do have very good connection. So they can watch 6 megabits, it's no problem. And in the middle, our Twitch, one of the biggest value of Twitch is we build our own CDN. We make huge investments into building POPs around the world, and building this replication network, the backbone capacity, and also the last mile, the edge capacity, pairing with ISPs. So we really have the whole system that's going pretty well. So a good problem to have is, so on the right is the quality ladder that the transcoder just spit out, all the way from 6 megabits 1080p60 all the way down to 160p30. And just using the number, of course, not everyone can watch 6 megabits per second, but assuming majority of people can watch 6 megabits per second. So 6 megabits per second times 3 million is the concurrent viewer, this the peak, which actually give us the peak traffic is 17, 18 terabits. That's actually not a small number. I just give you one reference point. In the news, I read Akamai during the World Cup, they claim their peak traffic is about 22.5 terabits per second, which means Twitch's peak traffic is actually not too far away from the Akamai's World Cup peak traffic. So which means we are really offering good service to our viewers, but on the other hand, delivering 17 terabits traffic, it's not very cheap. Okay, so here, after we talked with our product manager, he went back and think about, so this is the product requirement he kind of threw to engineers. So our next-gen codec format and the transcoder need to really satisfy these 2 requirements. So first of all, it must be live. We are not a VOD service. We cannot afford spending 9 days to encoding 1 hour of video. Every 1 second of video must be finished in 1 second. So we have to have live. So this is the must-have. And on top of that, our quality standard is X264 median. And maybe for live, so for VOD, people were saying this is not very high bar, but for live, it's actually pretty high bar. I will give you the detail in a minute. So live and high quality, then our goal is to save at least 25% of the bit rate. So based on these 3 requirements, the engineer go out and do all these studies, and our conclusion is using FPGA, doing VP9 can deliver this requirement. So now I'm going to explain this sort process where we do this feasibility study, what kind of information we have collected, what kind of logic we have followed, and why we come up with this decision. And when you're thinking about video compression, like a video standard, of course, intuitively, you were saying, I only need compression gain. I don't need anything else. But on the other hand, it's actually the opposite. The first thing you need to think about is the legal risk. And because of the situation of the legal risk, that determines the status of the ecosystem, of the decoder ecosystem. And based on that, that determines the codec company make investment in which format. And that determines the encoder's performance and determines compression gain. So the logic is from the legal risk to ecosystem of decoder, then the compression gain. So let me explain the legal risk first. For HEVC, as all you know, that instead of having 1 patent pool, the MPEG LA, now it has 3 patent pools. And what makes things even worse is there are some patent holders, they are actually outside of these 3 patent pools. And what this means is, compared with H.264, H.264, the cap is $10 million. So any company want to use H.264, just pay $10 million, you're done. It's great. But for HEVC, because 2 multiple patent pools, the cap is easily $40, $50 million. It's much more expensive first. The second is, even if you are a very good customer, you really want to sincerely pay each patent holder, it's very difficult. First, the 3rd patent pool hasn't published the patent policy, so their royalty policy yet. And also for other patent holders, you really need to negotiate 1 by 1. And that is actually impossible for a company to have an army of lawyers to negotiate with all these patent holders. So just not feasible. If you want to seriously pay the patent fee. On the other hand, VP9 is the opposite. VP9, Google said, so this is the quotation from their legal, the license scheme. So the first term said it's no charge, it's free forever. And the second one says, if any company decide to sue Google or sue any VP9 user, this company automatically lose the right to use VP9. Okay, which means so if I'm Samsung, I want to sue Google, then I just have to remove VP9 from my product, and that's also not practical. Okay, so based on this situation, from our study, we think VP9 the legal risk is much smaller, and because of that, they're looking at what's being supported in the browser. So the things we care most are Chrome and Firefox, at least based on our data. Majority of the browser traffic is on Chrome and Firefox. So they don't support HEVC, and I talked with their team, they will never ever support HEVC, but they support VP9. And one simple reason is HEVC is just so expensive. It's just Mozilla, just as an independent organization, they just cannot afford. But for, of course, Apple's Safari and Edge, I think, Edge, Microsoft Edge, they support HEVC. But the traffic on that is really small, so we kind of care less about. If for any of you, if you want to make decisions, you need to ask yourself, do you care about the traffic on Firefox and Chrome? If you care, VP9 is probably a better choice for you. And on the other hand, it's a mobile, and that's also interesting. Of course, for H.264, since the dinosaur age, on every device, everyone supports H.264. Okay, that's great. But on iOS, of course, Apple, they only support HEVC. They don't support VP9. They probably will never support VP9. On the other hand, iOS is only 15% of the market share. 85% is on Android. And on Android, according to our study, is so if you look at the Android spec, since 4.4, it actually supports HEVC. Sorry, VP9. And for VP9, it's all the hardware chips support VP9. And according to our study, according to our test, that they all support hardware decoding. But for HEVC, it's a little bit complicated. I actually asked many people, I asked many companies. I really don't get a very good answer. So one concern is because of this royalty risk, this legal risk, although Android 5.0 said you have to support 480p 60, for other resolution is depending on the hardware, and the chip do support HEVC. But because of the royalty issue, a lot of OEM manufacturers, they actually turn off HEVC support. So if you really want to deliver HEVC on mobile, for Android, you really have to test every device one by one. And at Twitch, at least at Twitch, we have seen 1,500 devices. So you really need to test all of it. So that's why I put a question mark on it. And again, for the connected TV, smart TV, and for set-top box, seems in this area they support both. Every device support both, apart from Apple TV. So this is the data that Codec put together in last year, about a year ago. So according to their study, they claim the VP9 installed base is 3.3 billion, while HEVC still big, but it's about 50% of that. And the reason is what I just described. So that's the decoder support. It's because of the legal risk, then come to the decoder support. And next come to the compression gain. So this cartoon is, so actually we have talked with a lot of, trust us, we have talked with a lot of companies, commercial encoder product. We want to just spit out this very simple requirement, and it's actually very hard. I just don't understand why. I mean, I work on codec chip before. I work for Umbrella. We build, our chip is used by almost every prestigious encoder, but so this seems to be a very, very high bar. And so I just cannot, sorry, I cannot, due to Amazon policy, I cannot mention any of the product name, the commercial product name, but I just use X264 as an example to explain why X264 median is a high bar. So according to our test, of course, it's based on our gaming content, based on our software, based on our CPU. If you use X264, only if you tune, like you use the very slow preset, you can just get 11.5% of the bitrate savings. And if you look at encoding speed, it's just encoded at a quarter of the original speed. So even at X264 median for our transcoding ladder on the big CPU, it's pretty big CPU, we can just run median. So running X264 very slow is not practical. It's just too slow. It cannot keep up, cannot deliver the real time. So that's X264. And this is my study note. So then because H.264 cannot deliver us the compression gain that we want, we just have to look at the next generation, HEVC and VP9. So this is my study notes. I guess many of you are experts, so I'm not going to explain each of them. But according to my study, my theoretical understanding, HEVC and VP9 in theory, they are very similar. They're really similar. They have a lot of common features. It's very similar. Which means from a standard, from theoretical point of view, HEVC, VP9, so not too much difference, although they're both much better than H.264. Okay, so the difference, the compression gain is really about encoder implementation. It's not about the standard. The standard, where the standard matters is the decoder support. Once the decoder support is there, it's really the encoder implementation. So we look at encoder implementation. So first of all, our test environment is the Twitch's AVR ladder, which I showed in the previous slides, 1080p60 to 160p30, based on our gaming content, based on the transcoder that we wrote, which we believe in last year's demux, we claim it's 70% more efficient than FFmpeg. Running on this almost $3,000 CPU, and we can just run medium. And for X265, we found we can just run ultra fast. And of course, ultra fast, the quality is pretty okay. It's actually close to, it's very similar to medium. Which means X265 running at real time, it's not designed for real time. It's maybe for VOD, it's fantastic. But for our application, it's not that great. And the even worse news is live-VPX. That's the only software encoder. Actually, at the time when we do the study, this is the only encoder in the world can encode VP9. And based on our setup, we can only run speed 6. So speed 6 is the fastest speed, basically means lowest quality. So speed 1 is the best, speed 6 is the worst. We found it's actually way worse than X264. So this again, I just want to state again that we think it's not to do with the standard, it's to do with implementation. So, which means we really, based on all these beautiful data, we just don't have a good VP9 encoder solution. And we find one, which is FPGA. So I have a video that on the left and on the right, one side is H.264 median, X264 median at 6 megabits per second. The other side is FPGA VP9 at 4.5 megabits per second. And I'm not going to tell you which one is which one. Please use your own eyes to see whether you can see any difference. And let me just play. Okay, I think I can stop here. All right, okay, so anyway, so can you tell the difference?
Left one is better.
Left one is better, okay. How much? Wide definition, okay. So actually you're...
0.7 dB.
Okay, right. So in this case, actually you're right. Actually, the left side is 6 megabits per second H.264. So you are right. So H.264 in this case is still better than VP9 4.5. Okay, so that's the result so far. So that's the story I want to tell about the VP9. Okay, so I talk about the VP9. This is something we want to put into production by the end of this year. And next, I'm going to say a few words about AV1. We really excited about AV1. And of course, it's not ready right now. The whole ecosystem not ready, but we believe that it will be the video format for OTT streaming beyond the 2020. When the whole ecosystem is ready. And of course, I think many of you have noticed this Moscow State University comparison. It basically says AV1 is great, but look at the encoding speed. It's 3,000 times slower than H.264. So different people have different opinions about that. So some say it's focused on the quality that is great. Some people focus on the speed, say this is not practical. We understand this, but on the other hand, as I said, this is really the reference code. It doesn't really tell it doesn't really represent the quality or speed of an industrial or commercial product. But what we excited about is most of the, actually majority of the high-tech company are part of the alliance. And we hope that in 2020, beyond 2020, this again become a single format that's supported across all the platform. Then we just go back to the very nice age of there's only a single format. We don't need to support both H.264, HEVC, AV1, or VP9, so just go back to one single. That will be a fantastic news for our operation cost for our accountant. So again, I want to say a few words about the switch frame. I think Tarek covered that in last year's demux. I just say a few words about that. This is some idea that I came up with in 2015. And so the idea is when Twitch moved from RTMP to HLS, so RTMP is a push-based streaming format. It's very low latency, but doesn't do ABR switching. So low latency, but not scalable, quality not great. We switch to HLS, which is we can do seamless switching. We have ABR algorithm, but the latency all of a sudden become 10 seconds or even longer. So so the 3.5 second that I mentioned in the beginning of this presentation, it is still HLS, but we do the chunk transferring. But there was one issue, I think, in the HLS streaming is the switching can only happen at IDR frame or keyframe. And because they're very expensive, so you really cannot put too many IDR, you cannot put the IDR frame too frequently. That's going to affect your coding efficiency. And the S frame, the idea is let's just allow some P frame also be switchable. So the idea is just turn off the motion vector prediction and do some K-back just reset at certain P frames. So without sacrificing too much video compression, we can actually switch. So so my team, Tarek and a few collaborators from Lab 126, we actually do the work, and that was accepted by the AV1. And it's so apart from besides the keyframe, intraframe, interframe, we have a switch frame in the AV1. And I hope beyond 2020 we can utilize this feature to do low latency, large scale live broadcast. That's the story I want to tell. And so a summary is we are a live streaming platform considered as a international TV stations on internet and our scale. In order to reduce the operational cost, we're building VP9 live encoding solution to deliver the video quality, 25 bitrate savings. According to our study, FPGA is the only available solution in the market right now. Because we want to do live, we want to do VP9, we want to do 25% bitrate saving. I talk a little bit about AV1, and we hope and we believe that it will be supported on all platforms. And for the switch frame feature, that we will be utilize that to do low latency scalable broadcast.